Hello students, we are going to study Poisson distribution. Poisson distribution is a limiting case of binomial distribution under the conditions n the number of trials is indefinitely large and p the constant probability of success for each trial is indefinitely small. So n is very large and p is small. Thus, the Poisson distribution is used to describe the behavior of rare events, where the probability of occurrence of the event is small and the total number of possible cases is sufficiently large. For example, number of printing mistakes in a book, number of accidents on a certain highway during year, etc. Mathematical definition of Poisson distribution. A discrete random variable x is said to follow a Poisson distribution if it assumes only non-negative values and its PMF is given by. So, P of x is equal to e raised to minus lambda, lambda raised to x upon x factorial, x taking values 0, 1, 2, dash dash, lambda greater than 0 and equal to 0 otherwise. So, here lambda is the parameter of the distribution denoting the average number of occurrence of an event. So, it is written by x follows Poisson distribution with parameter lambda. So, next point, physical conditions for the occurrence of Poisson distribution. The results of each trial is classified into one of two disjoint categories, say success and failure. Second, the probability of success p is very small. Third, the trials results independently. And fourth one, the number of trials n sufficiently large. So, mean and variance of Poisson distribution. Let x follows Poisson distribution. So, mean expected value of x is equal to lambda and variance of Poisson distribution v of x is equal to lambda. So, here mean is equal to variance is equal to lambda. Some real life situations. First one, number of calls received at an exchange in some unit of time. Or second example, number of defectives in a good lot of large size. Next point, Poisson distribution as a limiting form of binomial distribution. So, let x is a discrete random variable which follows binomial NP. Then under the following conditions, first one, n the number of trials is infinitely large, that is n tends to infinity. Second, p is the constant probability of success for each trial is infinitely small, p tends to 0. So, NP is equal to lambda is a finite constant. Then the PMF of binomial distribution approaches to the PMF of Poisson distribution with parameter lambda. So, here main two conditions are n is very large and p is very small. So, NP is equal to lambda. So, in case of this distribution, binomial distribution approaches to Poisson distribution. And for example, the average number of tankers arriving on a day at a depot is 15. What is the probability that on a given day at most 4 tankers arrive at this depot? So, solution, let x is equal to number of tankers arriving on a day at a depot and lambda is equal to average number of tankers arriving on a day at a depot. So, x follows Poisson distribution with parameter lambda is equal to 15. So, probability mass function of Poisson distribution x is p of x is equal to e raised to minus lambda, lambda raised to x upon x factorial, x taking value 0, 1, 2, dash dash. So, required probability. So, we have to calculate the probability of a given day at most 4 tankers arrive at a depot. So x less than or equal to 4. So we have to calculate x less than or equal to 4. Means probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4. Okay. So for the first probability of x is equal to 0. So e raised to minus 15 raised to 0 upon 0 factorial, so is equal to 0. Similarly, we have to calculate the probability of x equal to 1, x equal to 2, x equal to 3 and x equal to 4. Then probability of x less than or equal to 4 is equal to p of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4 equal to 0.000856. Thank you.